Hi friends, I hope all are doing good. Today let's see Stream API in Java 8 features. So most of the interviewers will ask about the Stream API and a few coding questions, simple questions, how to implement using like normal Java and using the Stream API. So it is one of the most important feature in the Java 8 and so let's get started. What is Stream API in Java 8? It is nothing but a stream is nothing but a sequence of data. It is actually help us in performing various operations with the data. So we will be dealing with the data only, right, in the implementation. So to perform any operations on such data, we will be using the Stream API and the data how it can be obtained to us it is from the several sources such as collections, arrays, or any IO like input or output channels and these streams providing us two types, that is sequential and parallel streams. We can perform the sequential operations when we obtain a stream using the stream method. So how we are going to get it? So we are saying we will be having two types, right? So how to do operations on that, how we will get that? Using the stream method we will obtain any of the stream over there, and the parallel operations with the parallel stream method. So interface has been added with the two new methods, stream and parallel stream in Java 8. And since interfaces such as we know, right, interfaces like list, set, dequeue, and queue extend the collection interface, we can get a stream or a parallel stream from the collection classes. So either we can get a stream, direct sequential stream, or a parallel stream from the collection classes that implement these interfaces. For example, we can get a stream from an array list object. So, a stream maybe in Java it is nothing but a sequence of data, and with the data we can perform various operations, and it is obtained from the several sources like collections, arrays, etc. And it is providing us the sequential and parallel streams. So, going forward, we'll see like how to implement using the sequential and parallel, how to create a stream, etc. in the upcoming slides. So here one of the note, we can even use the streams API independent of the collection. So we are saying, right, this collection interface that is going to extend, and we are going to implement, going to do operations from the collections, etc. So it is not like a mandatory thing. So we can use this stream APIs independent of the collection. So even we are not having the collection, we can use this stream API. So going to the next, characteristics of stream API. So we'll see what are the main characteristics of this stream API. We can create a stream from a source, perform operations on it, and produce this result. So whatever data we are having, right, we can from whatever source it is, either it is a collection, array, whatever source it is, we can create a stream on that and perform the required operation on that, and we can um, produce the result. The source may be, like I said, right, collection or an array or an input output resource. The stream does not, like, does never modify the source. So whatever source we are taking, right, so it should not change at the end. We are producing the result, right? So the result, like whatever result we are getting, right, but the stream whatever we are placing that and introducing the stream over that particular source, so it should not, it does never modify the given source. And remember that streams doesn't store the data. So we said, right, stream is nothing but a sequence of data. We'll do operations on that and we'll get the result, but it does not store any data. We cannot add or remove elements from the streams. Therefore, we can't call them the data structures. They do only operations on the data. So the first point is the like we can create the stream whatever source it is, we are having like collection array etc. So we can create a stream out of that and we can do whatever requirement, like whatever operation we have to do we can do, and we can produce the result. Second point, what it is saying, it is not storing any data, so we are only doing the operation whatever the requirement is, but stream will not store any data anywhere. We cannot add or remove elements from the streams, just we'll perform operations on that. So this is not the, so this is a case, right? We are not adding or removing elements, therefore we cannot also call a stream as a data structures. They do only operations on the given data. So streams operations are primarily divided into two categories: intermediate operations and terminal operations. So remember here there are two types of streams. In the previous slide we have seen, right, sequential and parallel. But what type of operations we are saying, it is going to do some of the operations, right, on the data. So what are the operations? Like it is again divided into two categories. So that is intermediate operations and terminal operations. So we'll see what are those operations in the next slide. So stream works on a concept of pipeline of operations. A pipeline of operations consists of three things: a source, zero or intermediate operations, and a terminal operation. So every concept will have, like, will be working on certain like concept, right? So stream here working on the concept of pipeline of operation. So basically what it is having, there are three things, like a source and source input, we can say, zero or more intermediate operation, so what we are going to do, and the last one is a terminal operation. So we'll see in the next slide what is intermediate and terminal operations. And the fifth point here is, in order to gain the performance while processing the large amount of data, Stream has a concept of parallel processing without writing any multi-threaded code. So we have said right before, we are like having two types of streams method, like sequential and parallel streams. Why we are going to parallel stream? So if you are having the large amount of data, stream is dealing with mainly with the data only, right? Data and its operations. So we are having a simple data, simple set of data, we are going to do operations easily. So what we have like a large amount of data. So in this case it is stream is providing, it is having a concept of this parallel processing, so without writing any multi-threaded code. So again going to some other method and going to write some other code, it is not necessary. So just we have to go for the parallel stream here, means parallel processing. All elements of a stream are not populated at a time, they are lazily populated as per demand. So what it is saying, streams, or like it is not at a time, at a single time it is not going to do, they are lazily populated. What is lazy loading? We are having a concept, right? Lazy loading, eager loading, these two things. So they are lazily populated means whenever it is called, it is invoked, then only it will get means it will take action on that, it will do that particular action as per demand, because intermediate operations are not evaluated until terminal operation is invoked. Here also, like important thing, until terminal operation is invoked means whenever this terminal operation is invoked, right, this has to be evaluated and invoked, because like what it is saying, intermediate operations are not evaluated until unless terminal operation is invoked, and it has to complete, then only these intermediate operations will get evaluated. Generally we can't use the same stream more than once. If we use the stream first time, it is said to be consumed. So whatever operation we are doing on the stream, right, we have to do once only. Then the like if you are doing the next time, the data already it is like whatever we are doing the operation, right, it is already generated like the output. The next time we are actually not going to do any operation on the second time. If we use the stream first time, it is said to be consumed. So these are the important points we have to remember about the Stream API. We can say these are the characteristics of the Stream API. The first thing, like it is we can like create a stream from any source, given source, and perform operations on that and producing the results. Second thing, the stream is not going to store any data, nor it is adding or removing any elements or data from the streams. Just it is doing the operations and such that we are not calling streams as a data structures. And these streams primarily like mainly divided into two categories: intermediate operations and terminal operations. And stream is working on the concept of pipeline of operations, means it will be having three things: a source means input, zero or intermediate operations, and a terminal operation. In order to gain the performance, means if you are having large amount of data, how it is going to process, it is providing us a parallel processing using the parallel stream. And the streams like whichever data, all the elements in the data are not going to populate at a time. They only populate lazily as per demand, because terminal operation, until unless the terminal operation is invoked, intermediate operations will not going to be evaluated. And streams we cannot use more than once. If you are using for the first time, then it should be consumed. So these are the important points we have to remember while using the stream API. Hope this clears. Going to the next slide. So we have talked like intermediate operations, terminal operations, right? So let's see. When an operation on a stream further produces another stream as a result, we call it an intermediate operation. So we are going to take a stream, and we are going to do some operation on that particular stream. Then it is producing the another stream as the end result. So this is called as a intermediate operation. This intermediate operations returns another stream as a result. Means whatever stream we are taking as a source, we are doing the operation, and we are getting the result also as a stream. As a result, we'll be getting as a another stream, right? They can be chained together to form a pipeline of operations. So such streams will be forming a chain to perform like another pipeline of operations. As the word intermediate suggests, these operations doesn't give end result. So this is a main point we have to remember here. Here, it is not going to give the end output to us. It is only doing some operation on the given stream, and as a output, it is giving us the stream only as a target result. So it is not giving the like main final result. So that only we are calling this as a intermediate operations. They just convert one stream to the another stream. For example, map, filter, distinct, sorted, limit, skip. These are the example methods for the intermediate operation. So we can also see this each method what it is doing in the upcoming slides. So main thing we have to remember for the intermediate operations are from a given source of stream, it is going to do some operation and giving us a another stream as a result. Okay, so only it is called as a intermediate operation, and means only it is converting one stream to the another stream. So some of the example methods are these. And what are terminal operations then? The operations which return non-stream values such as primitive or object are called as a terminal operations. So intermediate operations, it will give the stream as a result. Here it is not returning as the which returning as the stream values. Here it will return the non-stream values which can be primitive types or object. These types of values it will provide to us. So these uh, are called as a terminal operations. Furthermore, we can't chain them together. So we don't know, right, if it is going to give object can be anything, and primitive type. So all together we cannot combine and move forward, right? So we cannot change them together. They produce the end result. So they are producing the end result, so that only we cannot change together. Once a terminal operation completes, the stream is no longer valid. Whatever we are going to take the stream, right? It is doing the operation and it is going to give the end result, and such that it will complete its overall operation. So only we cannot use the same stream again, and such that it is no longer valid. Hence, we cannot use that stream again. For example, these are the example methods for terminal operations: for each, to array, reduce, collect, min, max, count, any match, all match, none match, find first, find any. So these are the examples for terminal operations. So the main thing the interviewer will ask, like, what are the intermediate operations and terminal operations, and how it is related to the stream API. Now, so intermediate operations are nothing but whatever source we are giving as a stream, it will do some operation and it will give the stream as a result, but it is not giving the end result to us, and it is going to be useful to chain together to form a pipeline of operations. And we are having a map, filter, etc. as the examples for the intermediate operations. And for the terminal operations, no, it is not giving us the stream values. It is directly giving us the end result of the stream. And after the terminal operation is complete, like the particular stream is no longer valid, and we also cannot use that particular stream again. For example, a minimum max methods are the examples. Hope this clears. Going to the next one. So we have seen, right, what is stream, what it like some of the important characteristics of the stream, and the operations, intermediate and terminal operations of stream, and how to create a stream actually in Java. So there are a few methods here using the stream.of method, stream from a collection using stream method and parallelStream methods, stream from an array using Arrays.stream, a stream using Stream.builder, creating an empty stream using Stream.empty, creating an infinite stream using Stream.generate method, creating an infinite stream using stream.iterate method, creating stream of a file. These are the ways of creating a stream in Java. So let's see one by one with examples. So the first we have seen this stream.of method. What it is taking this method is taking a variable argument list of elements like this. For example, if we are creating a stream of string type, stream of strings, how we are going to do, stream.of method we are using and going to give whatever string. So we are passing the data type here, right, wrapper class. So here we are providing the strings over here, and in the same way if we are going to do the integers, then this is the example stream.of. And how we are going to stream it. So integer array in the normal way, if we are doing this one, stream of integer, stream of array of integer equal to stream of array, directly this input we are going to give. So direct way we can do in this way, or else we can declare the array and we can stream it. So either way we can do using this stream.of method. It is a simple method, um, creating like it is taking only the variable argument list of elements. For the strings also we can do the same. So we can declare a string of elements, and in the next line we can declare stream of string variable name equal to stream dot of the, like whatever elements strings we are creating here, right? So we can directly give. This is a one of the methods. And let's see the next method. Stream from a collection using stream and parallel stream methods. We have seen, right, creating a sequential stream and parallel stream. So this Java util collection interface has stream and parallel stream, where we are having these methods in the collection interface. These methods are actually used to create the sequential and parallel streams respectively. These methods return a stream of elements over the collection on which it is invoked. So how we are going to give, just we are creating a list of string type, list equal to arrays as list. So happy learning through my channel. These are the um, values in the list. So just we have to created a list here. So how we are going to create a sequential stream and a parallel stream out of this list. So it is like a simple stream of a string, stream of strings is equals to list, whatever list we are having, right, we have declared, right, just we have to call the stream method over here. So if you are calling only the stream method, means it will create a sequential stream for us using most oftenly we'll use this one. And if you are dealing with the large amount of data, then we'll go for the parallel processing, that is the parallel stream. On the same list we can have the parallel stream also. So on the same list we are going to create the parallel stream. So generally this is used whenever we are having large amount of data. So this is the way to create a sequential stream and a parallel stream. So first we are going to have a list. So on that list only we are either having a sequential or the parallel stream. Hope this understands. Going to the next one. Stream from an array using Arrays.stream method. So here we can also create a stream from an array. So we are generally will be having the array, right? From that also we can create a stream using the stream method, which will be present in the java.util.arrays class, which accepts an array as argument. So if we see the example, string array equal to new string of, we are declaring all the best these string like values, and we are going to stream on that. We have actually seen in the last slide, right, a stream of method using the same way on the integers we have done here also. Arrays dot stream of, what we are going to give as an input in the stream method, whatever we are declared right here, the string type with the values, that whole string like array what we have created in the before line, we are going to give as a input over here. So the stream dot of and arrays dot stream are two commonly used methods for creating a sequential stream from a specified array, whatever giving array, right? These are the most common methods. This is the first method which we have seen, and this is the another way, like Arrays.stream, which will be commonly used in order to create a sequential stream. And both these methods return a stream when called with a non-primitive type t. So these streams, whatever we are creating, right, a stream.of using this method and Arrays.stream method, it will return a stream. So we'll see the next method, uh, stream using Stream.builder. So here we can create a stream using builder method. In order to get a stream builder, invoke the static builder method. So how we are going to create it? Now we have to invoke the static like builder method. This method returns an object. This builder actually will give us the object of type where it will be having of java.it will.stream.stream, capital S here we have to like a note here, and dot builder. This builder object is then used to add elements to the stream using add method, and then create the stream using the build method. So in the builder method, we are going to add the elements to the stream we are having, right? We are going to add the methods, and we have to create a stream out of that using the build method. So let's see the example, then it will understand. So builder of a string. So string type we are going to give here builder equal to stream dot, using the stream wrapper class we are going to build here. So just the first step here is the we are creating a builder over here. So for that builder we are going to add the elements whatever we are having, right, like the data we are going to add here using the add method, add of a dot, then we can add any number of elements using the add method over here. First before that we need to create a builder, then only we can add the elements for that using that particular builder. Then out of that, like first we are creating a builder, adding elements to that, and then we are creating a stream. So stream of string, so the same data type we are taking, stream equal to builder dot whatever builder we have been created, right, dot build. So we have created stream for that. So this is the way um, we can create the stream using the stream.builder method. So these are the three lines, right? We can reduce these number of lines and we can do in a single line. So stream, we are going to create the stream only, right, using the string data type, a variable name equal to the same stream dot whatever we are creating here, right, the builder we are going to create the same here dot adding in the same line, like using the add method, whatever elements we are having we are going to add using the add method over here, add of a dot add of b, etc. It will be going on whatever elements we are having we can add, and we are going to build that using the build method. So this is what we have done, right, in these three lines. The first step creating a builder, then adding elements, then creating a stream. So these three lines reduced to a single line. So in this way we can create a stream using the stream.builder method. So for now, yeah, this is the one type. And the another methods like creating a stream using the another methods will be continued in the part 2. Thank you for watching the video, and please do subscribe, and happy learning. Bye.